This is Contemporary Math, Section 6C. This section is the normal distribution. You may have heard of this before, also known as the bell-shaped curve. So, obviously called this because it's shaped like a bell. If you have a bell-shaped curve that's kind of spread out like this, it means that there's a larger standard deviation. Remember, the variation is more spread out. This type of bell would be a smaller standard deviation. So the normal curve fits this description. It's symmetric. It's a bell-shaped distribution with a single peak, and its peaks corresponds to the mean, the median, and the mode of the distribution. Its variation is characterized by the standard deviation. So I wanted to just look at this example. Now, let's see if I can turn the book a little better. Okay, so if you, the one on the left is a graph of the chest circumference of Scottish militiamen. For some reason, this is a really famous example of a normal distribution. Notice how this really closely matches the normal curve. Whereas this one, which is the population density of the 50 states, this would be more right skewed. Most of the states have sparse population per square mile, and then there's several states that have really, really high ones. So this one would be right skewed, meaning the mean would be higher than the median because we have a bunch of outliers. So this is not a normal distribution, but this one is. Enough of that. Sorry, hope that didn't make you dizzy. So with the normal distribution, we have what we call the 68, 95, 99.7 rule for normal distribution. So over 2/3, about 68.3% of the data falls within one standard deviation of the mean, which is in the yellow zone. So a little over 68% of all, if it's a normal distribution, 68% of all the data will fall either one standard deviation from the mean in either direction. Obviously, to the right is adding standard deviations, to the left is subtracting them. 95.4% will fall within this whole range right here. So within 2 standard deviations of the mean. And then 99.7% of the data in a normal distribution falls within 3 standard deviation. So that means there's like almost 0.3% way over here or way down here. Okay, so you're going to want to copy that diagram, and then that is just the words that describe the diagram. So let's look at the normal distribution of IQ scores. So first of all, let's talk about what kinds of things would fall under a normal distribution. So anything that's genetic generally falls under the normal distribution. And IQ is definitely a genetic human trait. So it's a really good example to use for the normal distribution. So notice here at the peak, there's the mean, median, and mode. So if I added 1 standard deviation, which is 15, by the way. Whoops, I didn't mean to do that. So plus 1 standard deviation, plus 2 standard deviations, plus 3 standard deviations. Going this way, this would be minus 1 standard deviation, minus 2 standard deviations, minus 3 standard deviations. So 68.3% of all humans will fall within this range. So now we're ready to talk about standard scores. Z-scores is what they're called. So a standard score is the number of deviations a data value lies above or below the mean. And to calculate the Z-score, you just take the data value minus the mean and divide it by the standard deviation. So let's look at a couple of examples. For example, I want the Z-score for 85. It would be the data value, which is 85, minus 100, which is the mean, divided by 15, which is the standard deviation, and that is -1. This tells me that my data value of 85 is 1 standard deviation below the mean because it's negative. Okay, the Z-score for 100 is 100 minus 100 divided by 15, which is 0, which is what we would expect because it's right there at the mean. And then the Z-score for this one is 115 minus 100 divided by 15, which is 1, meaning it's 1 standard deviation to the right of the mean. And that's how you find Z-scores. Normally, you will be working with like a chart. There's a chart of Z-scores in the book. I gotta find what page it's on because I can't ever remember. There's a chart on page 403 about standard scores and percentiles, which we're going to talk about right now. Page 403. So I'm just going to put that here, that there's a chart there that you can use. So a percentile is the percentile of a data value is the percentage of all the data values in a data set that are less than or equal to it. So example, if you scored in the 65th percentile on the SAT, which good for you, that's a pretty good score. That means that 65% of all the people that took the SAT scores, their scores were lower than yours. Oh, I already put the page number on here. I forgot I did that. The assignment, I think I'm going to change my mind on this. You're not doing the quick quiz on this. You're going to do the 6C handout, which I will post under files here in just a little bit. The only thing we're going to do this second week of the block is this section, because the handout for this is even longer. It'll take you longer than even the 6B assignment. I haven't decided how many points this one's going to be, probably 100. And then next week, we will finish out the chapter by going over 6D. And then there will be a quiz on the last day of the block. And I think the quiz will probably cover this part, finding Z-scores and percentiles, and then section 6D. So it'll just be a quiz, not a major test, because this assignment right here is going to be the bulk of it. It's going to be the highest scoring assignment in the block. All right. Thanks.